record. Just set this to record. I think I also forgot to record last time, and that's definitely disappointing, but no worries, because I'm going over the same exact stuff again, so there's nothing really that you're missing. Point of story is these three formulas will be our goal for all of the exercises in antiderivatives. Let me try one more that looks a little bit unusual, like problem number 35 here. This exercise has lots of various letters. Look at them. There is A, B, X present. So it turns out that I can check and see that actual variable here is only letter X, because we have dx that tells us that X varies, but A and B are nothing but the constants. So ax squared plus b that I can replace with a variable letter u. Then derivative of x squared will be 2x. So you can bring it in front and get 2ax with dx multiplied by it. And that gives us du. So we now going to replace the radicand here with a variable letter u. So we're gonna have a square root of u to work with. And then the remaining portion with x and dx here, I have with my du, but with no 2a present, which is okay. I'm gonna be taking this 2a away, dividing both sides by it. So I'm gonna have du divided by 2 times a, just like that. And then I need to take the antiderivative. So this 1 over 2a will stay on the outside. And I'm going to try to find the antiderivative of u to the power of 1/2, right? D. Because now the power rule comes into play. So I just need to add number 1, right? That's what it does all the time. So let me do it here on the bottom of this page. Add a couple of fractions. 1/2 with number 1, which is same as 2 over 2, right? 2/2 is 1. So we get 3/2. So this kind of arithmetic, I guess, we do all the time. So I hope you already feel okay with it. So we got 3/2 to the power of u. And we also have to divide this by 3 over 2. And don't forget about the constant, because we took antiderivative. So that denominator fraction 3/2 is what I'm going to have to reciprocate and turn into 2/3. Right? And then instead of letter u, I'm going to go back with this expression that had variable letter x, and that's ax squared plus b. So it's just a tedious expression to write down, yes. And then the power, as we already have, is 3/2. So we're done with that antiderivative. So I had radicand, and whenever I have parentheses or radicand, I always substitute that. So we looked at exercises up to 41, So today I'd like to continue with this story and show you how to do problem number 43 that will have one extra step. So when you integrate from 0 to 1, turns out 2x e power of x squared, then I have to use the formula above because I'm still trying to find the antiderivative. So the formula above says you can integrate e to the power of x. So the power needs to be clean letter x, not x squared. And that's why I'm going to replace this entire power of letter e with a new variable letter u, so I can do my integration. So when I take derivative, this is going to be 2x, derivative of x squared, right, as usual, times dx is equal to du. And this substitution is just what I need, because now we're going to integrate e to the power of u. And that's something that now I can find the antiderivative. The rest of this, notice it's exactly du. And that makes me feel real good. So now I'm gonna take away that integral sign and just write it as e to the power of u, but I don't put plus the constant, because now I need to return back to my original variable x. So I replace back letter u with x squared, and now the new part starts. So what we have here is e to the power of x squared. So x squared I need to replace with number 1, so it'd be 1 squared, and also with number 0. So it'll be e power of 0 squared, and then subtract them. So I just plug upper and lower values here and calculate and see that the first piece is going to be e to the power of 1, which is just e. And the second piece turns out to be equal to number 1, because e to the power of 0 is equal to number 1. And that's exactly what sections that we skipped for a while are talking about. So I'd like to move to section 4.3 that actually deals with this type of procedures. And today I'd like to get used to this procedure. So I'm gonna look at some problems here on the page that I just opened that start with exercise number 43, just to show you that all you need is to plug in upper and then the lower numbers, and then you'll be able to find the so-called definite integral. So when they put those numbers, they define the integral. So let us get used to this process. I'll do problem number 43 here. So this is section 4.3. So this says integrate from 1 to 3, so that I don't pay attention right now to this limits, but I just care about finding antiderivative for that sum. And to find the antiderivative, we're gonna use this first formula. So 3 stays, and then it'd be multiplied by t to the power of 3, right? Because it used to be 2, I add 1. And then I put same exact 3 in denominator. And then plus 7 times t. Now it's a variable t instead of x, so I put 7t. And that is what I need to replace with numbers 3 and numbers 1. That's so-called fundamental theorem of calculus statement. So we replace the upper number 3 here instead of my variable, and then I subtract the value when I replace with the lower number with number 1, just like that. And then we need to see what comes out. So looks like 3 cubed is 27 and 7 times 3 is 21. So when I put these numbers together, it'll be something like 48, right? And then also here we have 1 plus 7, which is going to be subtraction 8. And whatever the number comes out, I just have the answer. Happens to be 40. Okay, so I produce number 40, just like that. So you just plug in upper and lower, and that's all you care about. Exercise number 47 is going to be even more tedious here. Let me see what's going on in the next one. Minus 2 to 5. It's always tedious when you have those limits of integration, not as nice. So here we got a 2t squared minus 3t and plus 7 multiplied by dt. And now I'm going to have to take the antiderivative again. So it looks like it's 2t to the third power divided by 3, right? I added 1 to the power minus 3t to the second power, because it used to be power of 1. Now it's going to be 2 and divided by 2 plus 7 multiplied by t. So I'm going to be using these limits, -2 and 5. And again, just replace my variable with 5 and then with -2. And I think that it'd be more convenient if one used calculator, because otherwise it's very tedious and so easy to get mixed up in all of this arithmetic. So first of all, I plug number 5. Then I'm gonna, instead of my variable, put -2, just the way it is. And then I'm gonna take the calculator and carefully enter everything in that calculator. So I need to just carefully write it down. So this is 3, because at that stage, the calculus part is done. You just do arithmetic part of the course. And I guess I'm not really into testing on how you do the arithmetic, but you should be able to do it, right? So 7 times -2. So my advice is that you get a calculator. So let me find one for you. Remember that favorite free scientific calculator, the Desmos, right? And the Desmos will help. So I put in the parentheses 2/3 times 5 raised to the power of 3, just like that. Then you need to take the -3/2. So get a calculator and practice. I think if you do homework, some other exercises, you will see that they do have some problems that expect you to deal with all these nasty looking fractions. But what you can do is turn this into the decimal when you carefully plug in these numbers. So -2. I just put -2 in the parentheses, and then raise it to the power of 3, like that. And then we also need negative 3/2 here. Okay. And this is going to be also multiplied by minus 2 in the parentheses squared. See, we're almost done. And then plus 7 multiplied by, in the parentheses, negative 2. So there I have everything, and the calculator gave me the answer, whatever it is, 106 point something, 166666, dot, dot, dot. So we've got calculation for exercise number 47. And again, I know it is tedious, and whenever you have such nasty looking limits of integration, you always have to deal with this fractional things. In fact, sometimes even your upper and lower limits might look as fractions. So just get a calculator. It's never gonna go wrong. Let me try one more here for you, for practice sake. How about number 49 here? I'll do 49, and then I'll have you do similar to 49, something nice. So we integrate e to the power of t dt. Oh, what else could be nicer for integration? And after integrated, I need to plug in -5 and a 2 and see what will come out. So antiderivative is the same, e to the power of t, that runs from -5 to +2. So I'm gonna now replace t with a upper limit, which is +2, not negative, positive. And then subtract from that e raised to the power of -5. And that's it. So I got the answer. Please notice that you could also write this as a e squared minus 1 over e to the power of 5, but this doesn't really look any better. So you can just leave the answer in the same format. So what about if I ask you for a quiz, something nice like integrate e to the power of x dx, very similar to what I just did in the previous exercise, and I give you nice limits, 0 to 1. I'm sure you're gonna enjoy these, right? 0 and then 1. So that's our little quiz exercise for today. And the antiderivative, you just need to plug in upper limit and then lower limit of integration. And just put the answer in the chat. That's our little quiz.